What's up, dude?
What's up?
So nice. This is the last one.
What?
It's so nice. This is the last one.
Yeah, no. I don't like group meetings.
Yeah, group meetings are one thing, but doing group meetings online, dude, that's just a whole lot worse.
I'm sending you right now my work for problems 1 and 2. I thought they're pretty easy.
They were pretty easy. I thought they were going to be pretty easy.
Number 3 is kind of difficult.
Oh, really?
Yeah.
Dude, in this
But
class, I'm
I'm
getting an
sure
A
it's
minus by
not.
0.4%.
What?
I got an A minus, but only by 0.4%.
On what?
No, in the class, my overall grade.
Oh, really?
Yeah, in this class, got a 92.6%.
Why the difference? Did you bomb something?
Yeah, I bombed that second test. No, that first test, I bombed it hard.
You had a higher score than me this whole time.
Well, until that second test. We haven't talked about grades until like now. What are you at? You like at a 95 or something?
Yeah.
Yeah. That's what happens, dude, when you screw up on that first test.
Oh, well, this test will bump you up if you. Well, this test I feel like is the hardest just because it's all about the proving stuff.
Yeah, dude, is it cumulative or just proving crap?
Well, our like group quiz is all like that proving stuff.
I guess I'll look at the test prep. It'll let me know. Because if it was just like the last two chapters, it'd be easy. This proving stuff has been a nightmare. It's so hard. I'm looking at your work, dude. I sent out invitations to everyone. Tani sent an email saying she could make it, but we sent us her work.
What about soon?
I don't know. Soon hasn't texted me. She's the one. She likes to talk to you, man.
She hasn't said a word to me.
Maybe she's talking to Tani now.
Tony's like, leave me alone.
Yeah. Yeah. Dude, I got a big paper I got to finish today. After this is over, I'm gonna go to a class, and I hope
Write a
for
paper.
yeah, hope for everything I can get it all done in 5 hours. I've been sick lately, dude. I'll go to bed so early, and I can't get up till like 8 or 9 in the afternoon, 9 in the morning.
And I
I
went
go
to
to bed
bed
at
at.
9 o'clock and can't get up till 9.
That's a few. That just means your body's resting.
I know. Just I was going through a phase where I'd go to bed at 9 and get up at 5, and it was awesome. I'm trying to get your where the piss did this go? Well, sports PDF, desktop.
Do I look like pretty good right now? Or do I look wrecked?
No, dude, you look like you normally do. You look fine.
I'm meeting with a teacher to ask him for a letter of recommendation. That's
Oh,
what
it's
the
dope.
meeting's about.
Who's what class is that in?
Human biology.
That's dope, dude. Well, I am wondering where everyone is, but I'm not too sad they're not making it. I only
Hello,
say it because it's
Oh,
easy. Hey, soon. It
how
just
are
seems to get harder
you?
the more people we have.
So number one, simplify uh, 2 cotangent x times cosecant x.
Yep, I follow.
You see?
Yeah, soon.
That's what I got.
Yeah, I can agree with that.
2 cotangent cosecant x.
Wait, I don't know.
So number 2, sine 2x equals 2 sine x cosine x. This is number 2.
Yep. Well, so I got cosine equals 1, and then my sine equals 1/2. I mean, no,
Yeah,
cosine
1.
equals 0, and then sine equals 1/2.
But we need x. So sine x equal pi over 6, like this. Can you see?
I'm not looking right now, actually. I'm looking at the assignment.
Yeah, we have to simplify sine x. So we find sine x equal half. So x equal 30 degree. So pi over 6, 5 pi over 6.
Can you back your work up a little bit? It's a little too close to the camera. Cosine x. Yeah, all I can see right now is cosine x soon.
No, sine 2x equal 2 sine x cosine x equal cosine x. So delete cosine x. So simplify 2 sine x equal 1, sine x equal 1 over half. So the x is 30 degree and pi over 6, 5 pi over 6.
Cool. You know what might be easier since I'm having a hard time seeing your work is you did this last week. I think we just like emailed us pictures. That'd be easier to look at them. We could talk about them. I don't know if you're willing to, if you want to do that today, but I agree with you on the sine x equals 1/2. But I'm adjusting
Yes.
on the cosine x is equal to 0.
No, we don't need the cosine x. Cosine x already delete.
We get rid of it is what you're saying.
This.
Is 2x is equal to
Which problem is this one?
2.
Number 2. Number 2.
Wait, I'm pretty sure cosine was 0.
Because we're going to use a double angle identity, aren't we?
Yeah,
What?
double angle, and we can delete cosine x. So just the 2 sine x equal to 1, sine x equal to
Sine 2x is equal to 2 sine x
cosine x
cosine
equal
x,
to cosine x. So delete, okay?
because we're only solving the left side. Is that what you're saying?
Yes. So
Okay, I
delete
can follow you there.
2 sine x equal to 1.
Let's say next 2 sine x is equal to 1.
Yeah.
How do we know 2 sine x is equal to 1?
Sine x equal to 1 over 2.
Just because when you... So I didn't cancel the cosines out.
Look at this paper.
Yeah, we're looking at your paper, but we can't see too much just with where the camera's at.
So sine x equal to 1 over 2.
Thank you.
Do you understand it?
Is that because we moved the sine 2x over?
Yes. Sine x equal to 1 over 2, half.
So on that question, I didn't...
So x equal to,
It was cosine x equals 2 sine x minus 1.
Cosine x equals 2 sine x over 1.
1, which would equal sine x equals 1/2. Does that make sense?
yeah, sine x equal to half. We need the x. So x equal to 30 degree. Can you see?
Starting to. Because sine x equals 1/2, so 1/2, yeah, you go into the unit circle.
So we need the x. X equal to 30 degree. So we find the line 5 over 6, 5
Yeah, so
pi.
you get 3 degrees.
Look at this picture.
Yeah, so you get the 30 degrees, and then there's potential on the other side to have 160 degrees because we have sine equals 1/2 on both sides.
Yes, both sides. So pi over 6 and 5 pi over 6.
I see that, yeah. You say that's the answer?
Yes. Good job.
Hey, Cameron.
Hey, what's up?
Not so much, man. We're getting on working on 3 right now.
Oh, are you?
Tell us what you got for 2, though.
Sorry, let me go back and find it.
If you've done 2, if you haven't, we'll just.
I haven't done 2, but I've done 1
For 1, did you get 2 cosine x over?
over sine squared x. I got 2 cosine x over sine squared x.
Okay.
Is that what you guys got, or am I missing something?
We got 2 cosine x over 1 plus cosine x times 1 minus cosine x.
Yeah, and that factors out to 1 minus cosine squared x, which equals sine squared x.
Which equals sine squared x. Yeah, you're right.
Or not factors out, but multiplies to
Sine squared x. Cool, yeah. And then for number 2, we kind of got pi 6 and 5 pi 6.
Yes.
pi 6 and 5 pi 6.
Mm.
All right, so you're working on number 3 then?
Yeah.
All right,
Number 3 is very easy. Cosine 2 pi minus x equal to sine x. cosine minus x equal cosine x. We changing. And 2 sine x cosine x equal sine 2x. Can you see this paper? Cosine pi over 2 minus x equal sine x.
Okay.
Cosine minus x equal cosine x. So here denominator 2. So 2 sine x cosine x equal sine 2x.
Wait, he's doing from like 67. I was getting ready to go.
Yeah.
Can you understand?
Well, yeah, follow the cosine x, because cosine x, if you have a negative in there, it just goes positive. So that's just positive cosine x equals sine 2x over 2. Then we got to take that. Freaking cosine pi over 2 minus x is what's getting me.
Shoot. Is that the one where you have to do like cosine pi half times cosine x, like minus sine? I forget how to do it, but is that the right track?
I'm trying to look at stuff we got. That looks a lot like, yeah. Well, cosine of cosine of pi over 2 minus x should equal sine x.
Yes.
Yes, okay, I follow you there.
Oh, yeah, you're right.
It's equal to sine x. We got sine x times cosine x is equal to sine
2x over 2. And then, so sine 2x, according to the double angle identities, is 2 sine x cosine x all over 2. So the 2's cancel out, and it's sine x times cosine x.
Yes, that's it.
Yeah, they do equal.
Yeah, that was pretty easy. Okay, good. We're good there.
I was trying to figure out the pi half minus x, but I didn't realize it was on the sheet.
Yeah, that's kind of freaking me out too until I finally realized what was going on.
All right. Well, sweet. All right, number 4.
So we found
minus 4 sine x plus 1.
Yeah, 4.
So I found the sine x equal to t. So 3t square minus 40 plus 1 equals 0. So t equal 1 over 3rd over t equal 1.
Sorry if I sit here.
So we need to get the two different brackets or parentheses for this one, right? We need to factor it out.
Yeah, we have to find sine x.
Okay.
So we suppose t equal to sin x. So 3t square minus 4t plus 1 equal 0. So t equal to 1 over 30 third or t equal 1. So that means sin x equal to 1 over third and sin x equal 1. Sin x equal 1, x equal pi over 2. 90 degree.
All right. So when I factored it out, just make sure this is right. I got 3. Can you see it? 3 sin x minus 1 times sin x minus 1. Is that what you guys got?
Yes.
Factored?
So sin x equal to 1 or
And we set both of
sin
those
x
equal to
equal 1
0,
over
right?
12. Yes.
Okay. Thanks, soon.
Which one's this one?
Number 4.
Number 4.
Hey, Cameron, can I see your work again?
Yeah.
Yeah, I'm a little stuck.
So let me get where you can see it. Can you see that?
Back it up a little bit. I'm trying to see where you start.
All right.
You said x, okay, that's perfect. D plus 1 equals 0. You factored out the 3 sine x minus 1 minus 1, and then the 6 sine x plus, no, 6 sine x minus 1 again.
No, it's just regular sin x.
Oh, no, yeah, I see. Yeah, just sine x minus 1.
Sorry, I've got bad handwriting.
Oh, dude, you're fine. I'm not any better. Cool. And then, okay, so we factored out that far. That's not the answer, though, right?
No. So now we got to set both sides equal to 0.
Okay.
So we got to do 3 sin x minus 1 equals 0, and then solve those for those two answers, and then the sin x minus 1 solve for those two answers.
And sine x minus 1 equals 0. Okay, cool.
So that'll end up being sin x equals 1/3.
Yeah, I get that.
That's not on the unit circle, is it? Nope.
Sine x equals 1/3. Does that mean it's not an answer, or what does that mean?
That means we have to plug it into a calculator.
Yeah, I could do that.
We can find sin x equal to 1, x equal to pi over 2.
Are we looking for degrees or radians?
Radian.
X equal pi over 2.
Yeah, radians. We're looking for radians.
Okay.
Sin x equal to 1, x equal to pi over 2.
You guys getting 0.327? That's not what Soon's getting. When I put in my calculator, that's what I get for sine x is 1/3.
Sin x
Are you in radians mode?
I am in radians.
X equal to 0.34.
Yeah, 0.327. Well, since we're moving the sign over, are we doing arc sine?
Arc sine.
Oh, I think you're right. We do.
1 over third.
Yeah. So I'm with you, Soon. We do arc sine of 1/3.
Yeah. Okay.
Look at this paper.
Yeah, so soon I get the same thing. I get 0.34. Yes, I'm with you.
And then x equal to 180 minus 0.34.
And then we solve for the, because you said there's 2 answers for the 3 sine x minus 1/2? Because the other one's just the arc sine of 1.
Yeah, I don't know.
We found the arc sine 0.34. We need the sine x. So sine is 180 minus 0.34. The answer is 179.66. Look at
Okay,
this
yeah.
paper.
Yeah, that makes sense.
So wait, we take 180 and minus it by 0.34?
180 minus 0.34. Because the sine x equal to
Well, how does that work? Because 0.34 isn't a degree, that's a radian. So 180, that's, I assume, degrees, right?
yeah.
So should
So
we be solving
180
for
minus
the arc sine of 1/3 in degrees?
0.34, 179.66. This is answer.
There were some in the homework or in the practice that were like that too.
That would do radian, that would take degrees and minus subtract radians?
No, that they were just in degrees like that, like the ones that weren't on the unit circle.
Right, because if I solve for this for the arc sine of 1/3 in degrees, I get 19.47.
Yeah.
But if I solve for it in
Okay, we
radians,
need
I get 0.34. And I don't think we want to mix units. Does that make sense?
Yeah, no, I get what you're saying.
What do you think, Soon?
I don't know. Yeah.
we found the arc sine, right? Arc sine 1/3. So
Yeah, we
that
found it
is
in radian. Are you subtracting 180 degrees
0.34.
minus 0.34 radians?
And then we need not arc sine, we need sine x. So 180 minus 0.34.
But what Drew's saying is that 0.34 is in radian.
179.66. This is answer.
Yeah, no, but what we're asking soon is that 0.34, that's in radians. We found that in radians.
Yeah,
So whenever
radian, but that is the arc sine. Arc sine. That is not answer. We need sine x. So sine is 180 minus 0.34.
Yeah, but what we're saying soon is that 180 is in degrees. And so we're subtracting radians from degrees and we're mixing up units.
Yeah, 180 minus 0.34 equal to 179.66. We have to find radian, 179.66.
So is 180 is 180 not in degree values? Yeah, it's 180 not degrees.
It is.
Because the sine graph is y value. So 180 minus.
Are you also saying, Soon, that if we take the arc sine of a radian of radians, then it turns into degrees? Was that a thing?
So 180 minus 0.34 equal to 179.66. This is answer, 179.66. So you can you turn the radian 179.8866?
So we have to turn that into radians?
Yes.
Okay.
Because the
Shoot, I
sine
forgot
x
how to-
equal to 1, x equal pi over 2 radian. We needed to make a radian. So what is the radian? 179.66.
Don't you just multiply it by pi over 180 to get radians?
Yeah, what is answer?
3.135. We're taking 179.66 degrees to radians.
Okay, can you show me paper?
I just typed in. I just found a degrees to radians calculator on the internet and used that.
Okay.
So I did the easy route. That doesn't require.
To go from degrees to radians, don't we just multiply by pi over 180?
I think you're right.
Because if that is the case, then
I just can't remember what it was.
I can't fully remember either.
How to convert.
But if that is how you do it, it's 0.99 pi are the radians.
So the answer is a 0.99.
That's what because what I did and I'm not sure this is 100% correct, but if you can see, I just did the 179.66 times pi over 180, and I got
Yes.
0.998 pi.
Okay.
So I don't know if we
there are two answers. Sin x equal 1, so x equal pi over 2.
Yeah, I'm with you there. Follow that.
Pi over 2, and the other one is 0.995.
Yeah, degrees to radians is pi over 180.
Cool.
Yeah, you're right.
So it's 0.998 pi. Do we just round up to 1 or keep it at 0.99?
Well, it's 1.7966 pi over 180, right?
Yeah.
So do we just divide that by 180? Because I'm like, are you getting what's your answer you're getting?
I'm getting 0.998.
0.998. I get 0.3135.
Wait, really?
Because you're doing 179.66, right, times pi?
Divided by 180. And that's giving me 0.998 pi over 180. Okay, I see what you're doing. I just didn't multiply by pi. I just left it as pi. So that's
Pi
why
over
they're
180.
different. Yeah.
That's why you got the 0.998 pi.
Yeah, I got 0.998 pi.
But that's not like totally correct because we still got to divide the pi by 180, right?
Well, it's multiplication, so it would come out to be the same, right? Here, I'll do it. 179.66 times pi.
Yeah, no, you're right.
And then divide that by 180. Yeah.
So yeah, so 0.998 pi. We're on the same page as you soon? 0.998 pi?
Okay, and then pi over 2.
Yes. For the sine x minus 1.
Yes. Sin x equal 1, x equal pi over 2, and another one 0.998 pi, right?
So all of our answers are 0.998 pi and pi over 2,
Okay.
right?
Okay.
Cool.
Sweet.
Thank you. Bye-bye.
Hey, you're
I
welcome.
have to
Alright.
I have to go gym. Bye-bye.
Bye.
All right.
I gotta
Thanks,
get
soon.
study. Thank you, soon.
Thank
Thanks for
you.
working so hard. See ya. Good luck in your studies, guys.
All right. We'll see you. Good luck, guys.